Below that only, Walker circulation, El Nino and La Nina. That is impact on climate is there. No? In that only, we can see impact on Walker circulation, El Nino, La Nina. Let's see ocean currents map. South Pacific Ocean means Australia will be on the western side, South America is on the eastern side. And if you check the water movement, warm water will go like this, circulates back. Okay. Can I say this is East Australian current? What is this, guys? Humboldt current. Good. Can I say near South America cold water is there? Near Australia warm water is there. Okay. Now, guys, please say Australia, South America. Okay. Let us say trade winds. Trade winds will blow from east to west. Okay. So, when the winds blow from east to west, along with the winds, ocean water will also flow from east to west. Everything is pushed, even ocean water will be pushed. Now you tell, I have a tub, okay? Yes? You have a tub. In tub on the surface, warm water is there, okay? Now I will put my hand and push all the water, warm water from one side to another side. Can I say when everything comes like this, warm water accumulates on one side, cold water rises from the other side? If I push everything from one side, water comes up on the other side. So, what is going to happen in this particular part? We normally observe that there will be upwelling of cold water. Fine. Here there will be piling up of warm water. Piling up of warm water here, upwelling of cold water there. High temperature, low temperature. High temperature leads to low pressure, low temperature leads to high pressure. Wind will blow from high pressure to low pressure, rises near low pressure, it would circulate back. This circulation is called as Walker circulation. Okay, this is called as what? Walker circulation. Do you understand? Yes, nothing much. What is happening in South Pacific Ocean? Please understand, it's not North Pacific. South Pacific. Australia is on the western side, South America is on the eastern side. And we observe near Australia there will be piling up of warm water, and near South America there will be upwelling of cold water. So, due to this, high pressure on one side, low pressure on one side, wind will blow from high pressure to low pressure and circulate back. This circulation is called as what? Walker circulation. Okay, write down below. Near Australia, near Australia, there will be piling up of piling up of warm water, warm water and upwelling of cold water and upwelling of cold water is observed is observed near South America, near South America. Full stop. Near Australia, near Australia, near Australia, high temperature would lead to low pressure, would lead to low pressure, whereas low temperature near South America would lead to high pressure, would lead to high pressure. Wind will blow from wind will blow from high pressure to low pressure, high pressure to low pressure, that is from South America to Australia, rises near Australia and and circulates back and circulates back. Can you tell me where rainfall will be there, where rainfall won't be there? Australia will have rainfall, South America less rainfall. Okay, you write down. Due to Walker circulation, due to Walker circulation, Australia receives rainfall. Australia receives rainfall and South America doesn't receive rainfall. Yeah. Now, open atlas again. Can you see counter equatorial current present above equator? Counter equatorial current, is it present above equator? Pacific Ocean I am asking. Check in Pacific Ocean. Can you see? Is it present above equator? Yes, serious. Oceans are not so hot compared to land. As land is more hot, ITCZ shifts more in the northern compared to southern. So what happens in December also, mostly ITCZ will be above equator. If ITCZ is above equator, counter equatorial current will also be above equator. But once in a while, ocean waters will also get heated. It may take 3-4 years, but it will get heated. Can I say in the month of December, ITCZ shifts towards southern hemisphere? Yes, once in 3 to 4 years, when temperatures increases in southern hemisphere, that is South Pacific Ocean, ITCZ shifts. When ITCZ shifts, which month it is shifting? December. Once it shifts, you will have counter equatorial current shifting below equator. Now you tell, counter equatorial current will flow from where to where? Counter equatorial current will flow from where to where? West to east. Very good. Now, see here, I have surface water. Fine. Water will flow from where to where? West to east. Can I say this side there will be what? And which water accumulates? Guys, high pressure, everyone, see here, high pressure, low pressure. Wind will blow from where to where? High pressure to low pressure. This time it is from where to where? Australia to South America, rises near South America, and it would come back, correct? Can you see a circulation? Is it opposite to Walker circulation? Yes. If it is opposite, we use the term oscillation. What is it called? Oscillation. Which hemisphere the oscillation is occurring? Southern hemisphere. So it's called as southern oscillation. Which month? December 22nd, 23rd? Is it Christmas? Christ child. Okay, so it's called as what? El Nino Southern Oscillation, ENSO. Okay, now you tell who will get rainfall, who will not get rainfall. Australia doesn't get rainfall. South America gets more rainfall. South America doesn't get rainfall. It gets floods. South America prays to God, I didn't ask for floods. Please give me normal rainfall. That's El Nino. That prayers are called El Nino. El Nino Southern Oscillation. Now you tell, is Australia closer towards, is Australia closer towards Indian Ocean? Australia, is it closer towards Indian Ocean? Above Australia, do you have gaps? Yes or no? Yes. Now you tell, if cold water is near Australia, will this water enter into Indian Ocean? In Indian Ocean, temperature decreases or increases? Decreases. Decreases means less clouds. Less clouds means less rainfall in India. So India receives less rainfall during El Nino. Are you getting the point? See, this is considered most complicated one. Okay. But the point is, first complication for you is which is on the western side, which is on the eastern side. What is it? Australia is on the western side. South America is on the eastern side. Just remember normal circulation. Okay. So first you should draw in the exam like this. And you recollect anti-clockwise. Here warm water, here cold water. Leads to this. Exactly opposite is called as what? El Nino Southern Oscillation. Do you understand? Yes. You write down. El Nino Southern Oscillation. Draw this as. Done? You write below. Counter-equatorial current is mostly present above equator in Pacific Ocean. Once in 3 to 4 years, it shifts below equator, where water flows from west to east. That is from Australia to South America. Piling up of warm water is observed near South America and upwelling of cold water is observed near Australia. Next point. High pressure near Australia and low pressure near South America would lead to reversal of Walker circulation where wind will blow from Australia to South America, rises near South America, South America, and circulate back, and circulate back. This circulation, this circulation is opposite, is opposite to, to, is opposite to, is opposite to Walker circulation known as southern oscillation. In South America, in South America, this is known as El Nino. El Nino. So the entire phenomena, is known as ENSO. ENSO. El Nino Southern Oscillation. ENSO. All capitals. Fine. Yes. See, can I say if pressure difference is less, wind goes slowly. If pressure difference is more, wind will go faster. Same you apply here. Once in 3 to 4 years, this region temperature increases. If temperature increases, pressure decreases. Correct? Can I say if pressure decreases, pressure difference increases? I'll repeat, you see. Now it is 24 degrees Celsius. Let us say it became 28 degrees Celsius. This was somewhere at 900 and it became 800 because high temperature leads to low pressure. And let me say this is 1000. Earlier the pressure difference was 100, now it is 200. Now when you have 200, can I say speed will be more? Yes. So within Walker circulation, if at all the speed of circulation is high, correct? If the circulation is very high, then the circulation is known as La Nina. La Nina is similar to Walker circulation. Okay, La Nina is similar to Walker circulation, but what will increase? Speed will increase. Walker circulation and El Nino are opposite to each other. That's why you use the term El Nino Southern Oscillation. You won't use the term Walker circulation or La Nina Southern Oscillation. We won't use. Why? Walker circulation is similar to La Nina. Okay, what is the only difference? Pressure difference increases, speed of precipitation or speed of circulation increases. Can you write? La Nina. La Nina. Hyphen. Once in 3 to 4 years, temperature near Australia increases and due to which pressure difference increases. Pressure difference increases. Next paragraph. As pressure difference increases, speed of circulation increases and Australia receives very heavy rainfall and South America receives very less rainfall. Next paragraph. During El Nino, India will receive less than average rainfall, whereas South America, whereas during La Nina, India will receive more than average rainfall. Understand the meaning is El Nino means droughts, La Nina means floods in India. Okay, El Nino droughts, La Nina floods.